Hello and welcome to episode 8. What I want to start with is some small refactoring. For example, this one, I want to make a type alias. And let's put it somewhere more appropriate. Then next I want to have a helper function wrapping eval so that we don't have to do all this thing for each time we want to eval a string. I guess at some point it also makes sense to have a type alias for this thing, but I think that can wait. Okay. Let's see. That's okay, that works. Alright. Then I want to add a function in a global namespace that is not like a primitive function implemented in Rust, but actually implemented in Java itself. And of course I can't do that because we're defining it here. I guess I have to do something else then. Do this. sometimes a bit annoying in Vim that if I delete something, it will automatically become a thing I can insert again. Like paste. Let's see if this will compile. Not quite. Yes. I was just worried that because we are changing, like here we are borrowing glob mutably, that this one would complain. But I guess the Rust compiler is smart enough to realize that once this function returns, we no longer lending glob out here. So let's test a new function. And yes. Nice. Something I just realized. This is also an environment. Okay. Now for something fun. Fibonacci is always a fun function to implement to test out a new programming language. So the eagle-eyed among you might have spotted a problem with this, maybe even two. There's a quite easy to solve problem, which is I haven't implemented the minus function yet. The more complicated problem is that of course Fibonacci is a recursive function, but the environment in which we evaluate this function doesn't contain Fibonacci itself. I have some thoughts about it, but first let's solve this rather easy problem. We need to actually make sure that we can pass minus also. Simchar, yeah, it doesn't. Also wants to contain this. Then we have to implement minus. Which should be relatively similar to plus. Let's see, it's not quite as easy because we need to subtract the rest of XS from the first of XS. But I think there's something. Let's yeah, that should somehow. Let's see, I had okay, that's the pattern. Well, probably the compiler will complain about this because I need to put it as slice. But yeah, that's basically more or less what I want to do. Let's see what the compiler says. Yeah. I guess I really have to do a nested nested match here. And then of course an unwrap. Should I put this unwrap in eval string? Nah. That's putting too much into this function, because there might be reasons I want to eval a string but not assume beforehand that it's gonna be an okay result. But of course I have to put the ref in the right place. That would be very helpful. What's going on here? Yes. Alright, so minor should work. Let's test it out. Yes, we get 0. Okay. So what happens when we actually run Fibonacci? We should get a panic. Yes. Alright, so now to the more complicated problem. How do we make recursive functions work? Basically, this function has to point to itself, so we have to basically do a circular data structure, which is always annoying because you either need programming language which is like lazily evaluated like Haskell, or you can no longer just rely on values and have to use places. Places are of course annoying and should be minimized, but I think in this case we can't avoid it. I thought a bit beforehand about like how to do it, and there are like many options, but the one I want to do is basically change our environment type to use one cell so that we can refer to a function or to a value in general basically, but it's only really useful if you use it functions before it's actually evaluated. I think we do need to use it. Let me see. Yeah. Okay, and then a lot of stuff gets more complicated. because now we do have to wrap everything in a one cell. Let me see, is there, because I mean, in most cases we can actually just create the one cell and like really not make use of its functionality basically, because we basically just create it and set it at the same time. But it seems that somewhat sensibly there isn't actually a function for doing this, like a method for doing that on the one cell, because of course if you use that you don't actually need the one cell. But for purposes of having like the code more rectangular, will make everything a one cell, even though we only will need its functionality a few times. But I guess I can just write my own function for doing that. Yeah, I was thinking about like maybe it can like have like a single purpose trait for like on one cell to like make it look like it's like a normal like a built-in method of this type, but I'm not sure it's possible, and also if it's if it even makes sense. Like even if it would possible, if it would be a good idea. I guess now we have to make this generic. Okay. It's funny because there's a lot of stuff Rust requires me to do, which I do tend to forget. But I was actually almost wrote a mute here because I was like, yeah, I want to change the thing. But actually, of course, the purpose of a cell is that it is pretends to be immutable. Well, actually, you can mutate it once. Okay, let's see what the compiler. The compiler is gonna complain about a lot of things because we changed this without changing everything else. So actually we just want to test this one helper function, we will revert this change so we can see. Yeah. Why does it want to be? Yeah, it wants to be it needs to be debugged because it wants to show it if it if it was once set, then it would show what it is. So let's just do this. Because I mean, yeah, this should never fail. If it does, then I guess I'll have to deal with a less than helpful error message. But, well, maybe it's not. I mean, yeah, should be fine. But this didn't help, because it would still show debug. Does this work? Let's let me check. Let's Google quickly documentation result. Result, what does it? What does it have? So maybe this. It's or else, I think. Let's see. Yes. Yeah, it's just saying that it's never used, but it actually does compile. That's nice. So now that we did this, we can go back and make use of that Yeah, it's I'm so tempted to deduplicate some code here, but that can actually wait. Let's comment this out for now. So one still again, we just have to get it. Yeah. And then this too has to be put into a little helper. So actually if I run it now, this is also into, that works. So maybe, yeah. Well, I regret having to unwrap here, maybe. Okay, let's test this one. Okay, that works. Which also means I don't actually need my helper function, because actually Rust does provide me with what I want. I just didn't know how it was called. The parentheses alright? No, they're not alright. No, they're alright. Wait, where did I misplace the into? Hmm. Let me see. Does this work? Well, won't tell me because I deleted one parenthesis too much. And from is not. That works, even it's ugly as hell. So at some point I will convert all those into one cell from probably. But for now it will suffice. So Fibonacci. We want to put one cell here. And then we want to actually set it. Yeah, because we don't need to unwrap a new cell. A lot of unwrapping. And at some point you might ask why you use Rust if I'm like basically destroying all static analyze by just using so many unwraps, which basically makes everything just explode if it doesn't work out. Let's see if it compiles. That doesn't. Does this just need to be a string? Oh and then we can actually run it. And we have an unexpected unwrap in here. Okay, then let's see. Something like that, who knows? Yeah. Interesting. Why? So we do a function here. Because like here we are an empty one cell. Yes. But then somewhere else. Let's look at the backtrace. So yeah, it can't find it's uninitialized here, and for 6 we have a call here which goes somewhere in the list, and then here 147 is argument, and then 158 it's inside of the if, which is gonna be this if, I guess. And I think I've realized the problem. And yeah, it's why places are so annoying. Because of course, what am I doing is cloning a lot of environments. So I guess I have to make sure that if I clone an environment, I don't actually clone the places it contains. Because of course if you clone a value, it's still the same value. But if you clone a place, you suddenly have two places. And if you change one place, the other place remains entirely unaffected. So what can I do to make sure those places are not cloned when I clone the environment? I guess I can just wrap it into a reference counter. So, I mean, I would guess that if I can use into for one cell, I can also use this for RC. But I wonder if those actually like combine, or have to write like into. And I guess I have to actually, maybe let's see if here definitely has to be written out. But for the rest of the cases, it might just magically work. Well, definitely not here. Does this work? Is the Rust compiler smart enough to do the type inference? Let's see. Yeah, it might be a bit too indirect. That works. Except Fibonacci 5 does not return what I would expect it to return. Let's see. Except, of course, if the fifth Fibonacci number is actually 5. Which means, the sixth one would then be 8. Yep. Nice, that works. So now we have recursive functions. I guess that's what I wanted to achieve in this episode. And I have a feeling it's a long one again, but maybe that's okay. So see you in the next episode.